diameter has a radius of 85 centimeters. Which measurement is closest to circumference? Okay. So we have a circle. The radius is 0.85, which means the diameter is 1.7. We want circumference. C equals pi d. C equals pi times 1.70. And then we can multiply that. So 1.7 times pi, enter, we get 5.34. Circumference is 5.34 centimeters. 2. What is the circumference in centimeters of the largest circle that can be drawn on a piece of paper, 16 by 16 centimeters in size? Well, if it's a square, right? Think about it. It's a square. This measures 16, this measures 16, and you have to put a circle in here. Right, so that means the radius is 8. The diameter is 16, but the radius is 8. And we want the circumference, right? So, and again, radius is 8, diameter is 16. So C equals pi d. C equals pi times 16, and C equals 16 pi centimeters, or I don't know if they're, well, what number is this? Sorry guys, 2. You can leave it at 16 pi, or if you multiply 16 times pi, you get 50.27, or 50.27 centimeters is the circumference of that circle. 3, the diameter of a circular basketball rim is 18 inches, so we have a basketball, right? The rim, the diameter is 18, which means the radius is 9. What's the approximate circumference? C equals pi d. C equals pi times 18. They actually want you to multiply this one out. We got 56, rounded, 56.5 inches. B. 4, in the figure below, each side of the square is 8. So this is 8, this is 8, right? Which means the radius is 4. Right, what's the approximate circumference of the circle? Wow, really? C equals pi d. C equals pi times 8. C equals 8 times pi. 25.13, or actually point. I don't know why they wrote 0.12, but B would be the closest. It's 25.13. I don't know why they wrote 12, but that's the closest one. 5, the circumference on top of the soda can is 7.8 inches. What is the radius? Right, so here's your can of soda. The circumference is 7.85, and they're asking us for the radius. So C equals pi d. C equals, sorry, not C equals, I know the circumference, 7.85 equals pi times diameter. Divide both sides by pi. Diameter equals 2.49, 8, 7, etc. So let's round it to 250. So divide that by 2, and you're going to get 250. If you divide that by 2 to get the radius obviously is 1.25. Okay. 6, circumference. Again, same type question. Circumference is 72 pi inches. We want the radius, so C equals pi d. 72 pi equals pi times d, divide both sides by pi. That's gone. That simplifies. So the diameter is 72. And then if I divide that by 2, I get that the radius is 36. Right? So don't forget that. 7. Use diagram below to answer the following question. Kelly set a light fixture. The light shines on the yard in a semicircle with a radius of 20. So let me just write this is 20. What is the area of Kelly's yard that is lit by the new light? So what is this area right here? Well, it's a semicircle, right? Half a circle. So A equals pi r squared. A equals pi times 20 to the second power. A equals pi, 400 pi. Well, let's multiply that. 400 times pi, enter, is that actually the total area is 1,256.64. We're going to divide that by 2 because we're interested in half, right? So the area is 628. Did they round it? Yeah, they use 628.32 feet squared, and that's the only one that makes sense. Let's see. Right. 8. The pizza has a total area of 254.34 square inches, and it's divided into 3 sections. What is the area of portion covered with mushrooms? Wow. Total area is 254.34, and all 3 are evenly portioned, right? The same. It's 1/3, 1/3, 1/3. Well, divide that by 3. And you get, I mean, just looking at the numbers, it's going to be 84.78. Right? So 254.34 divided by 3, yeah, 84.78. Now that's a silly question. Very silly. 9. The largest possible circle to be cut from a 10-foot square board. So again, that's 10 feet, which means the radius is 5. What it will be the approximate area in square feet of the remaining board, the shaded region. So imagine, so the area of the square minus the area of the circle. That's what we're doing. So imagine you had the square, you punch a hole through it, which is the circle, and what you left over is that shaded part. So the area of the square, well, if it's a square, that's 10, that's 10. So area square is side times side, which is 10 to the second power, 10 times 10. So the area of the square is 100, so that's easy. Minus the area of the circle. Well, let's figure out the area of the circle. Pi r squared, area equals pi times 5 to the second power. Area equals 25 pi. Let's figure out the numerical value for that. It's 78.54. So 100 minus the area of the square, 78.54. And it's about 21.46. So what it will be the approximate area in square feet of the remaining. So we got 21.46, right? That's the remainder. So the only one that looks like that is that one. Ten bicycle wheels. Circumference, okay. 1 mile is 5,280 feet. A racer's bicycle wheel has a diameter. Right, so let's start drawing this. Here's a bicycle. Right, here's the. And what is it? It has a diameter of 2 feet and 4 inches. Ugh. So diameter is 2 feet and 4 inches, which is, so let's change 2 feet. 2 feet is 24 inches. Plus the 4 inches, you get 28 inches. So the diameter of this bicycle wheel, right, the diameter is 28 inches. Okay, we want to know, and it does 360 revolutions per minute. So 28 inches, 360 revolutions. So let's find the circumference. So C equals pi d. C equals pi times 28. The circumference is, let's say, 28 times pi, which is numerically 87 0.96 inches. So every time that bicycle goes one revolution, spins one, right, one full, the wheel turn, what do you call it, spins once, it travels 87.96 inches. But it says here that in a minute it does 360 revolutions. So it spins 360 complete times. So times 360. So 87, 28 times pi, enter. We get 87.96. 87.96. We're going to multiply that by 360. So in 1 minute, it travels 31,665.6 inches. All right, let's leave it in inches for now. To the nearest of a mile, how far will a bicycle travel in 5 minutes? So this is in 1 minute. So if I multiply that by 5, all right, so I multiply that by 5, it will travel 158,328 inches in 5 minutes. Okay, inches in 5 minutes. So, but we want the distance in miles. I'm gonna have to divide that by this. So, 158,328 inches divided by 5,280. 158,328 divided by 5280 equals, to the nearest of a mile, well, the calculator was 29.98 miles, so we're going to round it to 30 miles. Okay, so about 30 miles in 5. What? Hang on a second, there's something wrong. Take that back. Hang on, give me a second. So, the bicycle has a diameter of 2 feet 4 inches, 24 feet, 28 inches. 28 times pi, hang on, is 87.96. Good. So, and it does 360 revolutions per minute. I multiply that by 360. 31,665.6 inches in 1 minute. So if I multiply that times 5, $158,328, and then I divide that because, oh, that's, sorry, I divide. That's in inches, so I have to change this too. My mistake was dividing by 5,280 feet. No, this is what it is in inches. So this is 158,328 inches, and I want to change that to, well, let's see how many. 5,280 feet times 12 is 63,360 inches. Okay, that's what I should divide it by. So 1 mile has 63,360 inches, right? So if I divide those two, now I can get 158,328 divided by 63,360. Okay, I get 2.5. I'm rounding this. 2.5 miles. To the nearest tenth of a mile. Okay, so 2.5 miles. That makes more sense. Okay. All right. What's the best estimate for the area of the walkway around? So we want this area here. Right. If you think about it, the shaded area is the area of the big circle minus the area of the small circle. So if you have the big circle and you punch a hole and right the size of the small circle, whatever's left over is the shader. So the area of the big circle is, again, if that's 6, right, so that means this is 3, right, which means the radius of the big circle is 3 and 2, which is 5. So the radius I have, let me draw this again. Let me draw that again, a little bit better. Right, we know this is 2, and we know this whole thing, the diameter is 6, that means this is 3. So the area for the radius of the big circle, which is the line from the middle of the big circle to the edge, is 5. So A equals pi r squared, A equals pi times 5 squared. And 5 squared is 25, and 25 times pi is 78.54. Minus the area of the small circle. The small circle is just the circle inside, and if the diameter is 6, that means the radius is 3. So again, A equals pi r squared, A equals pi times 3 to the second power. 3 to the second power is 9. 9 times pi is 28.27. So if you subtract those two, you should get the area of the shaded region. 78.54 minus 28.27, we get 50.27. So that's the area, feet squared. That's the area of the shaded region. Okay. Which is B. 12. What is this? Worker baseball park is mowing the shaded region of the rectangular field below. The third region is a quarter circle with a radius of 140. How many square feet of grass will the worker mow? So the guy is mowing the shaded part, right? So the rectangle, so again, area of the rectangle minus area of the 1/4 of a circle. Right, 1/4 of a circle. So the area of the rectangle is 300 times 280. That's the easy part, which is 84,000. Now, area of the quarter circle. Well, area of the quarter circle is A equals pi r squared. So let's find the whole circle and then divide it by 4. Equals pi r squared. Area equals pi, and the radius here they give us to us is 140. So 140 to the second power. So take 140 to the second power and multiply by pi. Then multiply by pi. Times pi. Okay, hang on a second. Okay, 140 times 140, enter, times pi, enter, by 4, enter. We get 15,393.80. So subtract those two numbers. Okay, so try again. Right, and then so we get 84,000, which was the area of the rectangle, minus 15393.80. So the area that's left over after you subtract these two numbers, right, so which is the area of the rectangle, 84,000, minus the area of that little quarter circle there, we're going to be left with 68,606.2 feet squared. Okay. Yeah, so answer is C. 13, two congruent semicircles. All right. So this semicircle is the same as this. So this semicircle and this semicircle is the same, which means they're one full circle, right? Combined. What's the area of the shaded figure? So area, again, this would be area of the rectangle minus the area of the circle, right? Those two semicircles together would form one big circle. So let's find the area of the rectangle. The area of the rectangle is 3.5 times 1.75, right? 3.5 times 1.75, which is going to give us 6.125. That's the area of the rectangle. Minus the area of the circle. Well, it says here that the diameter is 1.5, which means the radius is 0.75. So area of the circle, A equals pi r squared. A equals pi times 0.75 to the second power. So let's take 0.75 raised to the second power, multiply that by pi, and we're going to get that the area is 1.77 rounded. Subtract those two, 6.125 minus 1.77, and we have that the leftover area is 4.3, I don't know what they're rounding it to, so 4.355 to the tenths, rounded to a tenth, so this is 4.4. So the final answer would be B, 4.4 square centimeters. 14, we have a circular garden, and the area inside, right, this area inside is A equals 804 feet squared, which is the closest to the radius. So what's the radius? Well, A equals pi r squared. Let's substitute for area, which is what we know. Divide both sides by pi. So what's 804? 804 divided by pi is 255. So that goes away. 255. Well, the calculator says all that, right? So I'm going to leave what the calculator says. Not going to round that. I'm going to take the square root of that side, right, and the square root of this ugly number. So radius is, and let's find the square root of that, 15.9977, so it's 16. So final answer 14 would be 16. Okay. All right. Not bad.